Yeah, I'm going to present the work of my colleague Armelle Gion, who is not on maternity leave, but couldn't come and be here. I want to acknowledge at the same time the role and the work of two students, Romain Dassonville and Guillaume Baloche, who contributed to this project as part of their master thesis. So the story is the implementation of the genetic evaluation on mastitis in France. As we all know, the clinical mastitis is very important from an economical point of view because of the associated increase in veterinary costs, low milk production, change in milk price, and the increase in risk of being culled. And we have been selecting, most countries have been selecting for resistance to mastitis through indirect selection via the somatic cell scores since many years. But we all know that clinical mastitis and somatic cell scores are not the same traits, and this indirect selection is only part of the story. So what we can do is to add to the tools that we have to fight against mastitis, direct observations on clinical mastitis. And in different parts of France, we had some kind of recording, not very strict recording since 1995, which was generalized and improved in terms of quality check and so on in the mid-2000s. And this is what we are going to use. These are information reported by the farmer to the milk recording technician during his or her monthly visit. So I'm going to talk about trait definition and data preparation, then the implementation or the estimation of genetic parameters in a univariate setting, then as you will see, given the low heritability, we need to improve the evaluation by including information on other traits. So we first have to estimate those genetic correlations with those other traits. And we included these indirect predictors of clinical mastitis in a multiple trait BLUP, which is in fact the multiple trait BLUP that we are using to compute our total merit index. Then I will be talking about reliabilities, genetic trends, inclusion in the international evaluation on clinical mastitis, and in our total merit index. The trait definition that we used is just a binary variable 0, 1, where 1 is the observation of a clinical mastitis case during the first 150 days of the lactation, and we considered only the first 3 lactations. And what I'm going to present is only on the 3 main French dairy breeds, Montbéliard, Normand, and Holsteins. The main problem that we have with the kind of recording that we have, or performance recording, is that in some cases, especially in the early years, we have the frequent possibility that 0 doesn't correspond to a healthy cow, but to an unreported case of mastitis. And so we spent quite a lot of time defining rules and testing different rules of edits, and by discarding, for example, herd year combinations with very, very low clinical mastitis incidence that we can think related to underreporting. Then we use different types of models for analysis. Given the binary nature of the trait, we use a threshold sire model first, but very quickly we move to a multiple trait animal model where these mastitis case were considered as a different trait for different lactations, but I'm not going to go through that, but all the genetic correlations that we got, whatever the breed, were above 0.85, so we moved to a repeatability animal model. This is a linear model, mixed linear model, which was used for this repeatability animal model. Nothing really special, with a herd year interaction for as fixed effects, months of calving by region, by year, and age of calving by parity and year. We had our own software for the threshold model, and we use the Armelle software Wombat from Karin Meyer for the estimation of variance component for the linear trait, mixed linear model. For the threshold model, I'm going to present only the results in Holsteins. We got an heritability on the underlying scale of 6%, which correspond after transformation to 2.3% on the observed scale. For the repeatability model, here you have the numbers of records for each of the breeds, the genetic standard deviation. The heritabilities were very low, between 1.8 and 2.3%, and the repeatability was low too. And given the fact that this heritability was not so much different from the threshold model on the observed scale, we kept this repeatability model for the rest of the study. Then, again, we were looking for predictors or correlated traits to improve the genetic evaluation on mastitis, and we used a method that I've developed 10 years ago for our total merit index, where first we used the results from the univariate repeatability analysis to compute pre-adjusted records at a cow level. That is, for each cow, each record, we first subtract the estimates of all non-genetic effects and the contribution of the dam. And we average this deviation, or these records corrected for the fixed effects, over the 3 lactations, 1 to 3 lactations, and we associate to each cow a weight, a particular weight, representing the amount of information in this average. Then we use these pre-adjusted records to estimate genetic correlations, assuming that we know that genetic and residual variances are known, using a Sire model because we corrected for the dam effect. And by doing that, we have something which is rather easy to implement and for which we can use a lot of data. Well, for example, for the Holstein, we were able to estimate this correlation based on 1.7 million daughters. And then we selected the best type traits and included them in in the estimation of genetic correlations between a large number of traits that we are using in our total merit index, and that's in total something like between 16 and 17 traits. We get estimates of genetic correlations that are indicated here for the Holsteins. I don't want to go through this table. I just want to show, well, the different colors represent different levels of correlations, and as you see, for clinical mastitis, we get quite a few colored squares that we are going to look more in details in the next slide. You see that first, the genetic correlations that we got are very consistent between breeds, with one exception that I will indicate later. And they are very consistent with what we find in the literature. For example, the unfavorable positive correlation between milk yield and clinical mastitis. The known high correlation that exists between somatic cell score and clinical mastitis, between 0.6 and 0.7. The quite strong favorable correlation, despite of the negative sign, between functional longevity and functional longevity on one hand, other head depth on the other hand, and clinical mastitis. Milking speed is a bit special in the sense that it is slightly favorably correlated with resistance to mastitis in the Montbéliard breed, while in the Holstein breed, it is slightly unfavorably correlated. Anyway, these are observations that were then used in a routine multiple trait evaluation. Here you have all the information that were used initially. Well, before edits, we had more than almost 21 million records lactations in Holsteins, and after edits, especially discarding herds that were suspected to have underreporting, this number of records was divided by 3 almost. The percentage of mastitis within the first 150 days, our criteria looks, in some cases, rather low. But again, it doesn't really describe all the cases of mastitis, especially mastitis after 150 days and in later lactations. Given the low irritability of the trait, here we have on the blue curve the reliability that we get for most bulls. For older bulls, this is due to a lack of reporting or lack of information for in the early 2000, and for younger bulls it just reflects the low irritability of the trait. Now, by moving to a multivariate analysis with using somatic cell count and longevity and other traits, we increase quite a bit the reliability of the bulls to a level which is very acceptable. And by including type traits in other traits in particular, we gain, let's say 2 to 3%, 2 to 3 points of reliability. Here you have the genetic trend in Holstein. In green, you have the trend that we had for somatic cell count with a decline at the end of the 90s, which was stopped by the inclusion of somatic cell count in our total merit index with a weight of 12.5% in 2001. And this prevented the further decline of mastitis, but except for the last point, where there were not so many bulls, didn't really improve mastitis, clinical mastitis. In Montbéliard and Normand, the trends are much flatter. In fact, not such a decrease. One very interesting result is, again, this routine evaluation was implemented in the last year and became official. Then we sent the data to Interbull, to the Interbull test run of September 2011. And here you have the genetic correlations between countries for somatic cell score, and it's really probably one of the most highly correlated at the world level trait. For clinical mastitis, the picture is quite different. And it's quite different because most of the countries, including France, before this clinical mastitis evaluation, are sending or were sending somatic cell scores as a proxy of clinical mastitis. Now we are sending clinical mastitis data, and we get a very high genetic correlation with the only country supplying, or country or group of countries, the Nordic countries, sending clinical mastitis, and we have a lower genetic correlation with all the others, which makes sense. So this led last year also to the inclusion, not last year, it is in February this year, to the inclusion of clinical mastitis into first udder health composites with, depending on the breed, a weight of 40 or 50% on clinical mastitis, the rest on somatic cell score. And we defined a new total merit index called ISU in France, where we increased quite a bit the weight on other health as well as on fertility composite, whatever the breed. The other health now has a weight between 14.5% to 18% in Holstein. So we hope now that we have the possibility to reverse the trend completely on mastitis. clinical mastitis. So as a conclusion, thank you was not supposed to appear now. But as a conclusion, we implemented a genetic evaluation on voluntary reporting of mastitis cases to milk recording technicians. We were not too sure about the quality of the data in the first place, and then this needed some edits, but especially the interval estimates of the genetic correlation between us and France and the Nordic countries. Let us think that this is very consistent, this trait is very consistent with strict data collection systems. Our genetic evaluations is done in 2 steps. First, a univariate analysis leading to pre-adjusted records, and then a multiple trait analysis, which combines direct information and correlated traits on an optimal way. And this is this combined value which is published and used as official proof. And this strongly increases reliability. So we have yet another tool to improve resistance to mastitis next to somatic cell score. And this has been included in what we consider as potentially much more sustainable breeding goal for the 3 breeds. Thank you.